In this video, we are going to discuss about photoelectric effect. Let us start with the definition of photoelectric effect. The phenomenon of ejection of electrons from the surface of the metal when light of suitable frequency strikes is called photoelectric effect. Let us take an example. A bowler is bowling a ball. When the ball strikes the pitch, you might have seen the sand particles get raised from the surface of the pitch. Similar to that of the sand particles rising from the surface of the pitch, here when the incident light is incidented on the surface of metal, what happens is the electrons are ejected from the surface of the metal. The electrons which are ejected from the surface of the metal are considered as photoelectrons. In simple words, the electrons are ejected from the surface of the metal by the incidence of the light, and here remember the light of suitable frequency is required, because if the frequency of the light is less, the electrons will not eject from the surface of the metal. The minimum frequency of light which is required for the ejection of electron from the surface of the metal is known as threshold frequency. Remember, always the electrons will eject from the surface of the metal if the frequency of light is above the threshold frequency. If it is less than threshold frequency, the electrons will not eject from the surface of the metal. A part of energy of photon is used to escape the electron from the attractive forces, and the remaining energy is used to increase the kinetic energy of electron. The energy which you are supplying in the form of the light is utilized in two ways. The first part is used for the separation of electron from the surface of the metal, or else to overcome the attractive force of the electrons with the surface of the metal. The second part of the energy is utilized to impart the kinetic energy to the electron. This can be mathematically represented as E is equal to W plus Ke. E is nothing but the amount of energy supplied in the form of a light of suitable frequency. W is the amount of energy required to separate the electrons from the surface of the metal. Ke is nothing but the energy imparted to the electron so that it can attain the motion. On further simplification, h mu is equal to h mu naught plus Ke. If you are willing to know the kinetic energy of the electron, you should subtract the h mu naught from h mu, that is energy supplied minus work done for the separation of electrons. Here remember, mu naught is nothing but the threshold frequency. As you know, the threshold frequency is the minimum frequency which is required for the ejection of electrons from the surface of the metal. In photoelectric effect, the number of photoelectrons emitted is proportional to the intensity of the incident light. If the intensity of the incident light is more, the more number of electrons are ejected from the surface of the metal. If the intensity of light is less, or else the frequency of incidented light is less number of electrons are ejected from the surface of the metal. Remember, photoelectric effect is readily exhibited by alkali metals such as potassium, rubidium and cesium. Photoelectric effect is used in photocells and solar cells.